first I'll take the queries that have been asked on the Google form, and then we will take queries from the live comments. So today we have got some interesting queries related to practical project issues. So let's take them one by one. And what I will do is I'll just share screen, put this question over here, and then we will begin. So let me take you to sharing screen. I hope the screen is visible now. So this first question is from engineer Ketan Mahajan, and he is a working professional from Jalgaon, Maharashtra. And his question is that I have designed a beam for residential building for parking floor. The beam is having a huge moment. The design strength specified for the beam was M40, concrete grade was M40, but contractor is able to achieve only M25. So on site, sufficient strength is not being realized on site. This result of M25 was obtained by core cutting and testing the specimen. Now I have to redesign the section by placing steel plates all over the three sides of the beam, and he has shared one image on the WhatsApp. How can I do it? Also tell me the connection details of this plate connecting to existing RCC beam and their calculation part. So I'll just share the image that he had sent, and it's interesting. So has anyone faced this type of an issue where they had to redesign or where they had to strengthen the beam because it was insufficient, or you had to enhance its capacity? Has anyone faced this type of an issue before? Okay, so no one has faced, it seems. So let's see what he has provided over here. This is a RCC beam, and on the three sides, he is suggesting to provide a plate 12 mm, all three sides. By placing steel plates all three sides. Okay, now what is the problem that I think? What is the problem that is going to be there in this type of connection is that suppose you were supposed to, let's say, have M40 grade of concrete, but in actual on-site conditions you are getting only an M25. Now what will happen with this type of a detail where Mr. Ketan is suggesting only plates on three sides is that let us take a section where uh, let's say it's a section where hogging is critical, hogging movements are, sorry, sagging is critical, sagging movement is more. Now if now for this kind of section where hogging is more, sorry, sagging movement is more, where will be your compression? Tell me. Let's say sagging movement case. Let's take a sagging movement case. So if sagging movement case is more, where will be your compression? So compression will be on the upper side, upper face. And let's say this is my slab beam junction, and this is my slab, this is my beam, and I'm taking a sagging moment case. So tension is at the bottom, compression is at the top. So on the tension side, and let's say my mu in the beam is, for example, mu in the beam is some 800 kilonewton meter, suppose. Yeah, this is my analysis moment. This is my analysis moment. And now in my actual beam, in the actual beam, as per M25 grade concrete, what am I able to achieve is, let's say, just giving some rough numbers over here. What I'm able to achieve over here is, let's say, 550 kilonewton meter. Okay. So because of M25 grade concrete, this is the strength I was able to achieve. This is the moment capacity rather I was able to achieve. Now the problem is that if I provide plates on three sides, what is going to be the issue? Acha, Mr. Ketan Majan has provided some values over here. Very good. So the problem that I can see over here, and I have taken a screenshot of the same WhatsApp chat he has sent me. So bending moment to be resisted by beam is 2100 kilonewton meter, and the moment capacity is 1182 kilonewton meter. Need to be designed for extra 918. So mu was 2100, and actual beam is able to only resist 1182. Now you want an extra of 918. Now the problem is, if you recall the concepts of doubly reinforced sections, I can put a plate over here, and this additional plate that I'm going to put, it will help me do what? It will be sort of an extra AST that I'm able to add. Okay. But the problem in this is this going to be sufficient? Tell me. You can recall the concepts of doubly reinforced beam design, and accordingly, if I want to enhance the moment capacity of any section beyond mu limiting, let's say, this is sort of mu limiting. So if I want to enhance the moment capacity of any section beyond mu limiting, what I do, I add AST2. So let's say I add AST2 over here in the form of these plates. But what the problem is going to be, that only adding these plates, will it enhance the capacity of this section? Quick yes, no from the live audience. Only adding these plates, will it enhance the capacity of this section, moment capacity? Tell me. So only adding these plates will not enhance the moment capacity, because you are only adding AST2 over here. What is missing? Missing is that you need to have, what is missing is that you need to have, or you need to have ASC added. So unless you add the compression steel, proportionate compression steel as per the stress, as per the similar triangles diagram that we have, unless you add ASC over there, this AST2 is not sufficient, as Mr. Amit is saying. So only adding these three plates will not be sufficient. You have to think of adding ASC, area of steel in compression. So now if this is a sagging moment case, my area of compression is over here. Let's say this is the region of compression. So what I need to do is, if you want to enhance the section capacity of the beam and you are adding these three plates, those might not be sufficient. You also have to think of adding a plate sort of thing over here, which will act as your ASC. This is number 1 point. So first thing you need to do is this. Then further what you need to do, so this now blue plate over here will take care of your ASC. So this takes care of your ASC. I'm adding these plates at the top. Okay. So this takes care of your ASC, and in a way this will be your AST2. Okay. This will be your AST2, and then you could have these web plate sort of thing for enhancing the shear capacity. So these web plates will be more helpful for you in taking the shear rather than flexure. So you right now concentrate on these two plates. One is at the top, let's call it as ASC. Other is at the bottom, AST. So this type of configuration change, first of all, you need to make. Now, how to calculate the capacities roughly? So a very rough way of doing it could be, that suppose you wanted a delta of how much? 918 kilonewton meter additional moment capacity was required. So first of all, you try to calculate the moment capacity these two plates could provide you. A very rough way of doing it, I'm saying. Correct approach would be on the basis of stress strain compatibility, but manually I don't think you will be able to do the strain compatibility calculations even in the software unless you are doing actual composite designs. uh, you will not be able to tackle this situation quite well. So I am giving you a very jugaad type of way over here, and what that will be, that you want this delta 918. So you have these two plates. Try to calculate, let's say zxx, or you can reverse calculate it. Of course, you calculate zxx of, or let me put it another way. You want 918 kilonewton meter. This is, let's say, equal to the stress into z mz, m equal to sigma z, sorry. Now this sigma, if this plate is firmly attached to this concrete beam, it's not going to have any buckling, or it's not going to have any, I would say, local buckling or global buckling issues. So you find out, you can take the stress as I would say around, in my opinion, you could take it up to Fy upon gamma m naught. Okay, so you take Fy upon gamma m naught and into Z. This is equal to this. From this you find out the Z. Once you know the Z, this is zxx. So once you know the required zxx, you try to back calculate this plate thicknesses. You already have the width of the plate because it is being limited by the beam width, RCC beam width. So you know the plate thickness, sorry, plate width, and then you can calculate the T over here. So in this manner, try to calculate T. Okay, you try to calculate T in this manner. Uh, so this is one way of jugaad work that you could do. Okay, and then for strain compatibility, so that this section behaves as a composite section, you may have to use some lugs. So you may have to drive in through some anchor fasteners. Okay, drive in through some anchor fasteners like this in the concrete, fill it with concrete slurry, and ensure that it is connected to these plates. Also do it for the bottom. Over here you will have to make gaps like this at regular intervals to take these web plates through and through. These web plates need not be continuous throughout the section. You could have it, let's say, at some intervals you could have these plates. Okay, and then this top plate will be running through and through. This is one of the possible ways. Mr. Ketan is having an interesting issue again. He's saying, how can I add compression plates on extra top where column is already cast above as well? Okay, so he had a case where in this itself, as he had said earlier, he has a planted column over there. So if you have a case of planted column, let's say this is my planted column and this is my section like this. Something like this, I believe. Now at the place of column, so these are my plates that I'm adding, let's say. At the place of column, I don't know how much wide is your column. How much wide is your column, I don't know. But then you could have this kind of an arrangement provided. So I'm saying, instead of having a plate as shown before, if it is being obstructed by column, have an arrangement like this. Something like this, where you have a column, planted column in place. At other locations, you could have the plate as shown before. Something like that you can think of. Okay. So keep these points in mind. This three plate arrangement is not sufficient. You will have to have some top plate. Basic calculation, you can do it this manner. And at column locations, you may have to come up with a slightly different arrangement, where arrangement like this can be provided. Is it clear? We had done a similar thing before, some years ago. We had done a similar thing where we had strengthened the beam by a similar arrangement. And what I will do is, let me just show you how that looked. So maybe you could come up with a arrangement like that. So for one of the projects we had done something like this. Are you able to see this section? So this was a capacity enhancement. This was a capacity enhancement project for one of the industrial plants, industrial structures rather, and its capacity had to be increased because of new and heavier equipments. So to each beam, this is something what we had done. So at regular intervals, we had provided these flats, if you can see. So these are to take the shear, okay. And now in section CC, this is arrangement something like this. Can you see over here what has been done? I hope it's visible. So here, if you see what has been done, there is a bottom plate. There is a bottom plate. Then there are these side plates at regular intervals. These flats on the web, these are at regular intervals. Then you have a top plate, as I was trying to explain you. Okay. Then there is an arrangement to fix these plates and everything together tightly. So there is a clamping arrangement that has been made. Okay, so this is a clamp that has been provided, an ISA 65656 at regular intervals. And then there are these cleats that have been provided fixed to the slab bottom. This is for sort of helping you connect these web flats. And then this is a clamping arrangement to tighten and to fix these entire section together in a very, very tight manner. So this is something that was given for capacity enhancement. And then this stepwise thing has been given how to do everything. So maybe you could come up with an arrangement like this. Okay. Okay. So I hope this answers. So work out something and you could think on these lines that I tried to explain. Very good. So this was Mr. Ketan Mahajan asking his doubt. Now let's go to next question. And that next question has been asked by Engineer Dinesh from India. And he's saying, I am designing, let me just copy. Where is it? I am designing an entrance steel roof for residential building of 20 feet by 26 feet, and architect needs same member depth in both directions, hollow steel beam in grid system, top of hollow section is same in both direction. My question is, either one direction of grid system beam will act as main beam, another direction will be secondary member. Which will be secondary, or both direction member will behave as main member because of same top steel. So right now I'm assuming that this 20 feet by 26 feet that you are saying, this plan, I'm assuming that it is going to be on all four sides. It is having some supporting arrangement. I'm assuming that because you have not mentioned it. So I'm assuming that on all four sides there is some supporting beam arrangement that is already there. This is my assumption. Now you are saying you are going to have grid beams like this in both directions, rectangular hollow sections. So it's a grid slab arrangement, and at certain intervals you are going to have these provided. I'm trying to show it by single lines. So at whatever distance you have provided them like this. Now what is the secondary beam? What is the main beam? Don't worry about secondary beams and main beams in this case. Okay. Don't worry about the secondary beams and main beams in this case. But yeah, I do agree that this might be acting as your short span. 20 feet may be acting as your short span. So, so because this is acting as a short span, this in the grid arrangement will attract more moment, let's say. So now while designing or while executing, what you can do is have this member as continuous member. That means have this member, don't cut this member. So have this member as uncut member, because you want both the black and pink members to be at the same top level. You have this black member as an uncut member, keep it end to end. Okay, and then these magenta color members can be cut in between these black members. Is this point clear? So first of all, follow this. So that means if I were to show you a section over here like this, how it would look, that your black members are going through and through whatever is the spacing that you have decided, and your magenta color members are being cut. Right now I'm taking a, okay, you want this same depth also, right? So something like this. So this magenta color members get cut and then placed at in between every black member. So first thing you do it like this. Now your second doubt was, so first you observe, you run, you model this, run this, see in which members, black or magenta, you are getting a higher bending moment, and then take this call as to, so then take this call as to which member to take uncut and which member to cut. My suggestion would be that whichever member is having a greater bending moment, keep it uncut, and the smaller bending moment members, keep it cut and join them on either sides like this. Now additionally, you also observe what is the nature of bending moment diagram you are getting. Okay, because it's a grid like system, whatever bending moment diagrams you get, one more suggestion would be that at all these junctions, just strengthen them by providing some top and bottom plates. Try to strengthen this junction of hollow sections by providing some top and bottom plates like this at every junction. So maybe if in the plan view I was to show you, in the plan view, this is my hollow black color line, black member, and this is my magenta member. This is the plan view. Magenta member is like this. My suggestion would be to have a lap plate, something like this, at top and bottom to strengthen this junction between the magenta and the black. Your next question was, for slenderness check, what will be the length to be used in grid system steel beam? So for this black beam, about its minor for this black beam, about its minor axis, okay, about its minor axis, it is getting support of this magenta member at every location, at every regular interval. So this distance, whatever it is, this distance L becomes is the Lx or Ly for this black member. Okay, so for black member, the Lx or Ly shall be the distance between this magenta beam. Lx Ly means for lateral torsional buckling or for flexural buckling about the Y. For the flexural buckling about the X, that is given as Lz. Let me use the STAD nomenclature. So Ly and Lx is for lateral torsional buckling length. Lx and Ly will be the distance between these magenta lines. And Lz shall be the full 20 feet that you may have to take. But Lz will be rarely critical, so you don't have to worry about it much. For these magenta lines or for these magenta beams, because anyway they are going to be cut at each location between the two black members, it's Lx, Ly, Lz, all three can be taken as the actual member length of the magenta line. So this distance between the two black beams This becomes the LX, LY, LZ for the magenta beam. Okay, I hope that is understood. Mr. Tamilarasan is asking, in grid system we need to release for secondary beams. No, but then the entire purpose of providing grid beam is lost. If you provide secondary beams as released, the entire purpose of providing grid slabs or grid beam is lost, isn't it? So you don't release it. Abhayji was asking, I think, in relation to the earlier doubt, beam column strength per yard. I think he is asking in relation to the strengthening question, and he's saying बीम कॉलम जंक्शन पर क्या ट्रीटमेंट होगी, क्या ट्रीटमेंट होगा वहां पर भी तो कंक्रीट की स्ट्रेंथ कम होगी. Okay, so he is saying in this strengthening question, at the beam column junction, what shall be the strength treatment given? So for beam column junction, you will have to see the column. Let me draw a sectional view. This is my beam and this is my column. Now for beam column junction, this junction, right now you will have to analyze the column and look for what is the column strength. Is the column strength less, more? What is it? Depending on that, uh, you will have to find out the treatment necessary for the beam column junction. Generally, we had done again a steel plate jacketing for the project that I was showing you. So the columns were also inadequate. So we had done a column jacketing, and at beam column junction also we had taken some plates. Of course, it was slightly complicated, but then we had done the steel jacketing over there. Now Mr. Ketan has to check what is happening at the beam column junction in his case. Okay, and then a possible jacketing system may have to be introduced for the beam column junction also. Very good. So this was question that we had. Now we will move to the next question. This is asked by engineer Sujoy Patra. He is joining us from Kolkata, and he's saying his question is, in EQ design, what is it? Are you able to see the screen? In EQ design, how to check for spec X or spec Y, that means response spectrum cases, how to check for response spectrum base shears, value is okay or not. What do you mean by okay or not? I mean, if you want to compare those values, maybe you will have to do some manual calculation. So if you have to cross check, do some manual calculation and do and then compare. Now I don't know. I am at least not able to do a manual calculation for a 3D building running response spectrum model cases. So at best, maybe you could take a simple stick model in ETABS, having masses at different levels assigned, okay, and then try to run its model response and try to compare its model response with mathematical calculations. So, I mean, how to check whether RSX and RSY are matching, are okay or not? I guess that is the only way. Refer or compare it with manual calculations. And because we are not able to do manual calculations for bigger things, bigger projects, that's why we are relying on the software, right? It is as good as saying how to test whether a calculator is working well or not. So the easiest way to do it is to simulate some small problem that you can do it manually and cross check. Okay. Good. So this was his doubt, although I'm not sure what the question was, but okay. Next doubt is uh, by engineer Abhijit. He is joining us from Pune, and he's saying first we are taking the Google form questions, then we will take the doubts questions asked in the live comments. So engineer Abhijit from Pune, he is saying what are the what kind of parameters have to be considered in structural drawing while working with MEP team. So if you are working with MEP teams, let's say if your MEP will have, let's say, uh, plumbing and sanitary. I am talking more in terms of building right now, building like projects. Then let's say they have electrical, and let's say they have HVACs. Okay, so let's break down this MEP into these three main trades. So from the live audience, what do you think as a structural engineer? What things of these MEP services we should take into account? Yes, tell me. So plumbing, sanitary, you should be seeing, and in fact for HVAC electrical also, one of the major pain point we have with MEP is the positioning of their openings or ducts that they want. So the openings or ducts position should be well coordinated before. Otherwise, it becomes a real pain point later on. So we want to save ourselves from core cutting because it's a failure. If you have to core cut in the slabs, it's a failure on the coordination, or it's a failure on structural engineers and MEP team, right? Because it was not coordinated. So core cutting is a last resort, and it shows improper coordination. So we want to avoid that. So openings, ducts should be well coordinated before all the service with all the service trades. Sleeves, if required, through beams mainly because that is a pain point. These should be well coordinated before, and the positions of the sleeves through beams should be identified by the structural engineer, and accordingly during the casting itself proper sleeves can be placed in the beam at strategic and desired locations. Another pain point would be, let's say, another aspect that you would like to cover well in advance is the air conditioning units, or let's say they are going for some AHUs. So these locations and their loads and their positions and their placement should be well coordinated before. I'm facing some cold today because I went for a swim yesterday, so just a little bit cold from that swimming session. Anyway, so air conditioning placement, their positions, the positions for AHUs, if you are going to place chillers, their locations. Usually these days, roof is a location where all these will be placed, or you will have some service floors where these things are placed. So their loads and their probable uh, locations have to be coordinated well in advance. If for from electrical perspective, positions and locations of generators, okay, any other electrical equipments should be well known beforehand. Uh, Although not directly related to MEP, but escalators, elevators, and any special requirements for escalators, elevators, especially escalators, is a pain because you have to properly plan the escalators beforehand. So these positions and their loadings, etc., should be well coordinated in advance. What else is remaining? Yeah, any point I'm missing? Maybe from a general perspective, the refuge areas. You have to know the refuge areas where you are going to have refuge areas. Accordingly, you will have to uh, accordingly you will have to consider their loads. What else? In multi-story buildings and especially in bigger projects, the fire tender locations, fire tender path may have to be well known, because you'll have to apply load accordingly. Where all, or on which all locations the fire tender, that is a fire brigade truck, is expected to come. Those locations have to be well known and coordinated. From a sanitary point of view, especially for residential like buildings, the position of STP also becomes important. In smaller projects or in commercial projects, what happens is those STPs, nobody likes to keep them in the outside, because outside area is a prime real estate. uh, so nobody likes to keep STPs these days outside the building. Many people want to adjust their STPs in the basement itself. So the position of STP and its location has to be also thought well in advance. Plus the water tank positions, fresh water tank, fire water tank, these locations. Plus I would say drainage of storm water, so not sewerage, storm water and water in parking areas, their drainage and their uh, proper treatment. Treatment in the sense that the water, there should not be any water logging in basements, water logging in the uh, parking areas. And for that you will have to take help of the MEP consultant and find out how much water is expected to come as a storm water or accumulated in the parking. And for that you have to have necessary channels, and that should be diverted properly to the sort of tanks. So to my mind, these are the aspects that you could coordinate in advance with the MEP team and save yourselves from later discomfort. Okay, so this was engineer Abhijit from Pune. Next we have engineer Nihal from Kerala. He's asking, only 50% of rebar can be curtailed in a column at point. Uh, is it 50% of AST or 50% of bars? It is 50% of bars. But if you are curtailing 50% of bars, you are also curtailing in a way 50% of AST, right? So I don't understand how these two things are different from one another. But yes, usually it is the number of bars. So if you have 12 bars in the column at a section, not more than 6 bars should be curtailed, and so on. Good. Next question is from engineer Dinesh. He is saying how to calculate the depth of fixity for pile foundation in order to give socket depth of pile. So depth of fixity calculations, you refer to IS 2911 part 3, no, part 1 section 3, and if I remember correctly, appendix C, I guess, appendix C of IS 2911 part 1 section 3. I think this is the code where they have given the depth of fixity calculations. Okay, but I think it's not for the uh, piles resting in hard strata, that is end bearing piles. I don't think it's for end bearing piles. I think those calculations are for the friction piles. So I'm not sure, but you look at the IS 2911 part 1 section 3. Okay, so these were the questions asked on the Google form. Now let's take up the questions that have been asked in the live comments. So one by one from the top, Let me just take it. Engineer Sadashiva is asking, what's the difference between K factor in ETABS and design parameter K in Stat Pro? So in the Stat Pro, the K factors are to do, I mean, they are the same in a way. They are the same in a way, but the K factors in Stat will help you to take the appropriate effective lengths. Now, if I am talking in terms of IS 800, let's say steel design code, then the KX will be for lateral torsional buckling length, KY will be for your flexural buckling about Y, KZ will be for flexural buckling about Z. So in terms of steel design in StatPro, this is what the design parameters KX, KY, KZ are going to do. What are the K factors in ETABS? Those are mainly to do with your sway calculations, or again they are in a way effective length factors. So ETABS does something like this. Usually it will do a non-sway movement and a sway movement. Now those sway movements get multiplied by a factor that ETABS calls it as K2, and the non-sway movement gets multiplied by a factor that ETABS calls it as K1. Now usually this, if you read the documentation, the K1 will be for the non-sway. It will be for the non-sway part of the column movement, and K2 will be for the sway part. Okay, this is mainly as per concrete design I'm telling you. But if I were to say, let's say for steel design in ETABS, it will calculate this K1, K2. K2, I think it will always take it as 1 if you run a P delta analysis. So the K2 factor ETABS takes as a default, I guess, is 1 if you run the P delta analysis in ETABS. Yeah, P delta analysis in ETABS. If you do not run a P delta analysis, this will be calculated by the alignment charts given in the IS 800 2007 appendix. And in this manner, ETABS will calculate these K factors. So in STAT is not able to calculate the effective length factors. You have to give it to STAT. ETABS is able to do it on its own. If you come to RCC design, again, STAT will not do anything for you. You have to do all the calculations. And again, in RCC, if you are doing it as per IS 456, what STAT is going, ETABS is going to do, ETABS will calculate stability coefficient Q, and if Q is greater than 0.04, it will call it as a sway frame and accordingly calculate the sway factor. If it is less than 0.04, it will call it as a non-sway frame, accordingly calculate the K factor. This thing that I explained, K1 times non-sway moment plus K2 times sway moment, this is more like the American way of design. This thing is given in the American code mostly. Okay. Mr. Sadashiva is adding, in ETABS, K factor for column is calculated by considering sway factor, and we don't do that in Stat. Yeah, in Stat Pro, it's not able to do any effective length calculation. So it is we, the user, who has to do all the length calculations. Then next question is from Engineer Islauddin. Please compare STAD versus ETABS in terms of PEB. I am currently using STAD. If I switch to ETABS, what are the pros and cons? You are using American code or Indian code? I don't know if you're using American code or Indian code, but my general suggestions would be that if it's a PEB like structure, my general suggestion would be if it's a PEB like structure, that means a regular shed like structure, it's not a building like structure. Okay, then my suggestion would be that STAD will be better for shed like structures. I'm saying STAD would be better than ETABS because for shed like structures, you don't need the modeling techniques that are available in ETABS, especially like all floor, all story, one story, similar story. All those things are not required. Instead, modeling of these shed-like structures is easier, I would say. If I were to talk load calculation, load application for this type of structure, which is not orthogonal strictly. Orthogonal means it's not having multiple story levels. It's practically speaking only one story level, so to say. So load application is also simpler in STAD as compared to ETABS. Now, if I talk in design terms, for IS 800 2007, ETABS makes a very big mistake that ETABS does not consider, or I would say ETABS even considers slender webs in moment calculation. So I don't know if you're aware or not, as per the IS 800 2007, slender webs in moment calculation have to be ignored, but ETABS is unable to do that. STAT does it, ETABS is unable to do that. Also, if you have built up sections like you may have in your case, and if you make those built up sections using section designer in ETABS, ETABS will make a mistake because it will take the warping constant as 0 for built up sections that you have created through section designer. And if CW is 0, it will give you artificially low movement capacities, artificially low compression capacities, and that again will be a problem for you. So strictly for industrial shed like structures, if you are want to choose between STAD and ETABS, I would say STAD is a better software for these kinds of structures. But if you had a, let's say, pre-engineered building, which was a multi-story pre-engineered building, okay, these days, uh, multi-story steel structures are also being done in your prefabricated, pre-engineered plate sections. So if it's a multi-story structure, then you could think of using ETABS because ETABS then will have the advantages of modeling load application that it has for multi-story systems. Is it clear? And for Indian as well as American, I would say these advantages of STAD will stand over the ETABS, whether you are using Indian code or American code. So for industrial shed-like structures, go with STAD instead of ETABS. Okay, good. Mr. Akash Babar is asking what should be the maximum spacing in between hybrid piles. I don't know. What is hybrid piles? What is hybrid piles? Just clarify hybrid piles. Mr. Amit is saying, Engineer Amit is asking, what is the proper way to model a flared column in ETABS? We have discussed it before also. One of the ways could be that maybe you could give a tapered section property. There is an option to give tapered section property. So give that in ETABS. And in that manner, you could achieve a flared column, maybe whatever section you have. I'm drawing the elevation, of course. So you could achieve a flared column by giving a tapered section. Otherwise, you could introduce nodes in between and you could give rectangular sections of different cross-sectional area to have a tapered effect. Third thing is you could model that column as a shell element where you give the in elevation of the column, you give variable dimensions to model the flaring, and then the thickness of that flared column can be given as the shell thickness. So these two or three approaches you may use. Mr. Akash Babar is saying hybrid piles mean end bearing plus friction. So from the usual logic, I would say end bearing plus friction for if I'm assuming it does not have bulbs. If it does not have bulbs, I'm assuming. So if it's a friction plus end bearing pile without bulbs, I would say three times pile dia should be a good spacing. And it's not maximum, it is minimum. Maximum, there is no limit. It's the minimum spacing. Okay, maximum has no limit. Maximum you decide, but the minimum spacing would be around, I would say around three times the pile dia is a good spacing to have. Then Mr. Akash Babar is asking, second mode is second mode as torsional or mixed mode allowed? First mode is torsional translation. No, so if your first mode is translation, that means in one of the directions your building is behaving properly. In the other direction, building has some behavioral issues where torsion is dominating. So you try to adjust the sizes of your columns. You try to uh, uh, you try to modify the sizes of your columns, sizes of your beams. You may try to reorient those columns, and then you will see better behavior in the other direction also. So as you said, first mode is already translation. That means in one of the directions your building is behaving well, but in the other direction the building has some behavioral issues. So you try to reorient or reframe, make some modifications in your framing systems maybe to have a better behavior in the other direction also. Okay, first try that. If nothing works, I mean, it is allowed. You're allowed to have torsional modes so far as it does not go into extreme torsional irregularity. So if it does not go into extreme torsional irregularity, you are allowed to go for torsional modes also. Just that you will have to have the uh, response spectrum analysis done. Then Mr. Abhijit Sate is asking for high-rise building how to do value engineering. It's not a topic that can be covered in 5-10 minutes. It will take a lot of time. So I don't think I'll be able to answer this right now. Uh, yeah, I mean, it's not a thing that I can speak for 2 or 3 minutes. So I'm not going to take this up. If you have any specific doubt, just ask. Mr. Akash Babar is saying, what should be the effective length factor for RCC shear walls? ETABS does not calculate it for walls as it does for columns. No, so for if you are worried about the effective length factor for walls, about the minor axis mainly, because you have defined it as a shell element, I think it will not. I need to check, but yeah, I think it does not calculate. So if you are very worried about the effective length factor, maybe is there any option to overwrite? I'm just thinking. Once you assign the peer labels, is there any option to overwrite that? I'm not sure. I'm not able to recall right now. I think there must be. If you assign peer labels to your walls, there might be some option to overwrite the effective length. No. Now see, generally in shear walls, the moment about minor axis is not such a big issue. Moment about the minor axis usually is not such a big issue. So I am showing you a plan view. This is, let's say, my local 3-3 and this is local 2-2. Now usually in a shear wall or RCC structural wall, It's going to be the movement about 3 direction. That is going to be the major movement. Now, if in your case you are having moment about 2 axis also, that is critical for you. What ETABS anyway does is that about the 2 axis, it will design it as a column, just like a usual column. In fact, about 3 axis also it does the same, but about 2 axis also, it will design it as a column, considering the minimum eccentricity as well. So I think that minimum eccentricity may take care of the additional movements that might get generated. But for effective length, I'm not sure how to deal with it. So I think when we will calculate the, when ETABS will use the IS 456 clause 39.1, it will use that this formula, something like this. What is the formula? L by D whole square, maybe something like this, right? So it will use that moment due to slenderness. It will calculate that, and I believe it is able to calculate the L by TW, where not L, height. Let's take it height, where H is the height floor to floor. So it will calculate that H upon TW. If it is more than 12, I think it will treat it as a long column and add the slenderness moment, additional slenderness moment. So even if you are unable to calculate the effective length, I think let ETABS do the slenderness moment, additional slenderness moment calculations. I think that it will do properly. So it will take care of the slenderness effects. Clear? Okay. So I think we have answered all the doubts, queries on the Google form. We have also covered all the queries in the live comments. So is there any doubt, difficulty, issue that you have further? I'll just give 2 minutes if you have any doubts further. Yes. Any doubts, questions? So today I think we had a good session where we were able to take more practical queries. I was suffering from some cold because, as I told you, I went for swimming yesterday, first day of swimming. So maybe therefore, yeah. Anyway, it will get better. Yes, please. Anything else? So I think then that's it for this session. We will close our session over here. Next weekend, again, we will have a live session. So during the week, as I have told you before, also, you can keep posting your queries. Mr. Abhishek Mishra is saying Mankar design ka video chahiye. But we don't have anything right now. Maybe in the future we will come up with something. But as of now, we don't have anything on it. Silo bunker. Yeah, I got your what you want. Right now we don't have it, but maybe in the near future we'll come up with something over there. So if, as I have told you before also, the same Google form you can use for putting your live queries, not live queries, putting your queries throughout the week also. And as you know by now that once a week we conduct this live session where we try to answer your queries. Okay. So the same Google form can be used throughout the week. So that's all for this week then. Have a good week and see you next time. Bye bye.